In this video, we're going to look at how to find the greatest common factor of two algebraic expressions, specifically monomials. So let's take a look at how we found the greatest common factor of two numbers, and we can found the greatest common factor of expressions similarly. So here are two examples. We can compare the process. So on the left side, we have two numbers, 210 and 108. And to find the greatest common factor, again, factor means a number, usually smaller, a number that can go into 210 and 108. So whatever the answer is can go into 210 a certain number of times and can also go into 108. Now, one way we could do is to list all the factors of both numbers, but for big numbers, it could be tedious. So a very efficient solution is to use factoring. So we break down 210 as 21 times 10, and 21 is 3 times 7. And notice we cannot break down 3 and 7, so we have to stop here. But we can break down 10 as 2 times 5, and 2 and 5 don't break down. So that's why I got, if I put them in the order of non-decreasing, so it's going to be 2 times 3 times 5 times 7. And for 108, we also break down, let's say it's 2 times half of it, 108 will be 54. And 2 we cannot break down, but 54 we can break down as 2 times 27, and 27 can be broken down as 3 times 9, and 9 can be broken down as 3 times 3. So the factors of 108 can be 2 times 2 times 3 times 3 times 3. And notice when I write down the factors of both, I line up the same number. This will be very helpful. I mean, it's not mandatory, but this is going to be very useful for us to determine what numbers to bring down, because this way we can see what they have in common very easily. So they both have a 2, they both have a 3, and that's it. That's all they have in common. So we will bring down these two numbers, 2 and 3, and multiply them to get 6. So that's how we found the greatest common factor of two numbers. Now, this method can also be applied to finding the greatest common factor of two expressions with the variables in there. So, for example, 25b, and we can break down 25. We do have to do the factoring separately for the number and for the variable. So 25, of course, is 5 times 5. And the b cannot be broken down. So we just kind of like a 3. We cannot break down 3. Well, we cannot break down 5. So b, the same thing. We cannot break down b. So we are just going to put a b right there. Now, next expression is 15ab. So 15 can be broken down as 5 times 3. So I line up a 5, and I create a new column for 3. And for the variables a and b, and notice ab we can break down as a times b. So the b, I'll line up with the b in the first row, but a, because the first row doesn't have a, so I'm going to have to create a new column for a. So this way, I'll make sure that all the numbers, same numbers are lined up, different numbers create new columns, and all the variables are same variables line up. For example, b and b is here, and the 5 and the 5 is here. If there's nothing to match, we always create a new column, for example, for this a. Again, it's not a mandatory, but this way can help us see very clearly. They have the same number 5, and they have the same variable b, and then we bring them down and multiply them to get 5b. So the greatest common factor of these two is 5b. Now, if you can see, for example, by looking at the numbers 25 and 15, if you know 5 is the greatest common factor, you may not have to do this. So you can just say, okay, the greatest common factor of 25 and 15 is 5. Because for smaller numbers, you might be able to see it. And for b, then you have to find the greatest common factor for the variables. And B and AB, they both have B in common. So you bring down B. And so you can get the answer in like 1 second probably. But if you cannot do that, and the factoring will always give you the correct answer. All right, so let's look at these two more examples with more variables in here. And so we could, if you are able to look at them, say 48 and 20, what do they both have in common? Well, one number can go into both 48 and 20. And if you can see that, let's say it's 4, and you can just write down and the 4. And then you look at the variables a5 and a3. What do they have in common? Well, they both have 3 copies of A in common, so that's the answer. But if you have trouble seeing this, and you will do factoring. So break down 40. So first I'm going to write down 48 a5 and 20 a3. I'm going to write down the breakdowns. So 48, if you break down 6 times 8, and 6 can be broken down as 2 times 3, and 8 can be broken down as 2 times 4, and the 4 can be broken down as 2 times 2. So all these numbers now. So we have to, when we do factoring, we have to make sure we keep breaking down until we cannot break down that number any further. So notice that we have 2, 2, 2, 2. I'm going to put them in the non-decreasing order. So we have 1, 2, 3, 4 2's, and times the 3. Okay, so I'm going to draw the vertical lines to separate the numbers. That would be clear. Now, for A5 just means 5 copies of A. So you just have A, and A. So 5 copies of A's. That's the breakdown. Now, next, let's work on 20 A3. Now, 20 we know we can break down as 4 times 5, and the 4 can be broken down as 2 times 2. So it's going to be 2, 2, 5. So let's try to put the number 2 in here. And notice the first column is a 2, so they match. So I can put my 2 there. And the second 2, we also have another column for 2, so I put my 2 there. But for the number 5, because we don't really have a column of 5s, I cannot put it here because it's a 2. I cannot put it here, it's a 2. Cannot put it here, it's a 3. So we're going to have to create a new column for that number. I probably should have saved a little bit of space. Maybe let me do this so I can have all the numbers together. So I'm going to move this A. I'm going to move this A to here. Add a new column here. So I can put the 5 here, so I can have all the numbers together. And now 2, 2, 5. So I have all three factors of prime factors of 20. Next, we're going to break down A to the third, and we know by the definition of exponent means 3 copies of A, and which we can line up with the A's we already have. Okay, so now we can write down our GCF, and you can see, look for the columns with 2 numbers. So they both have 2's, they both have another 2, and the single 2, single 2, single 3, single 5, and they both have A, and both have another A, both have another A, and the single 5, single 5. So these, the ones with 2 of them are the numbers, and sorry, 5 is single, we shouldn't do that. And A, so we have 2 2's, and we have 3 A's. After we bring them down, we're going to multiply them. So 2 times 2 is 4. A times A times A is A to the third. As you can see, that's the same answer as we got by looking at them. Okay, and so if you understand that A3 and A5 mean 3 copies and 5 copies, so they should have 3 copies in common. It's always going to be the smaller exponent. So that's a tip that we can use. So now let's look at this one here. So we have the numbers 56, 14, and 42. So again, if you're able to see that 14 actually goes into all 3 numbers. 14, of course, goes into 14. 14 also goes into 56 4 times, and 14 goes into 42 3 times. And then you will be able to determine the greatest common factor for the numbers will be 14. And for the variables, 2 copies, 3 copies, and 2 copies, they of course have 2 copies in common. So pick the lowest. And the 2 copies, 2 copies, and 3 copies, they also have 2 copies of y in common. So you will be able to just look at them and get the GCF. But again, if you have trouble doing that, then you will have to do all the breakdowns. So 56, when you break them down, it's 7 times 8, and 8 is 2 times 4, and 4 is 2 times 2. So you're going to have 2, 2, 2, 7. And for the variables, I probably should do the numbers first and then do the variables so I can have all the numbers together. So 14 will be 2 times 7. So I'm going to write down 2, line up with the 2, and this line up 7. And 42 is going to be, breakdown of 42, it's 6 times 7, and the 7 is 2 times 3. So I'm going to have 2 times 3 times 7. Now, I don't have a column of 3, so I'm going to have to create a new column, put 3 there. And I do have a column 7, so I'm going to line up this 7 with the 7 I already have. Okay, so we're done factoring the numbers. So now let's create a new columns for the variables. So start with the first one. X squared means x times x. Y squared means y times y. So I'm going to separate them. Now, x third means we have 3 copies of x. Well, because I'm out of x's, so I have to create a new column. Now, 2 copies of y, line up with the y's we have. And the last one is 2 copies of x and 3 copies of y. And notice this is an x, so I cannot put my y here. I'm going to create a new column for y. So after that, you will be searching for a number or a variable that can go into all 3 of them. So which means you're going to look for a column with 3 numbers or 3 variables. So I found 2 are containing all 3 of them, 7 are containing all 3 of them, and this x, and this x, and this y, and that y. All the other columns have either 1 number or 1 variable. So we're going to bring down those columns called GCF. So we have a column 2, and there's a 7, there's a x, x, and a y, and a y. So we're going to multiply all of these together. 2 times 7 is 14. X times x is x squared, and y times y is y squared. And notice this matches the answer we got there. So again, if you can look at the numbers and determine the GCF, and you don't have to do all of this work. And for the variables, actually, it's easier. You just always pick, for example, for all the x's, you pick the one with the lowest exponent. 2, 3, 2, 2 is the lowest. And for the y's, do the same thing. 2, 2, 3, pick the lowest, which is 2, and put them all together. But if you can have trouble seeing it, you can always use the factoring method.